Next, let's look at how to convert digital signals to analog. We want to produce an analog output using our digital systems. To do this, let's think of our application as making some music, right? So we want to take our MP3, we're going to decode it, and we're going to output it as an analog signal. And what we need to drive a speaker is a signal that looks like this. Rather than just a square wave of ones and zeros, we need something that varies over time, because that's the actual motion of the speaker. We have to vary that signal and make it look like this, right? So the way that we do this, to use what's called a digital to analog converter. And the way that one of these things work is really cool. The basic idea in digital to analog conversion is we want to take some digital value, some binary value like this byte, and convert it into a voltage. And the way we do that is we convert this thing to 92. That's our level. That's the value of this number. Then we multiply it by our voltage divided by the number of possible levels, right? So the idea is this numerical value, 92, is going to be converted into a voltage, in this case 1.18 volts. And the way we do that is with a digital to analog converter. So this is a simulation of a digital to analog converter that uses a voltage ladder. And basically what we have, this is a very simple version that produces only 4 levels. This is my implementation, but it's very similar to how it works in our actual ARM processor. What we have here is we have a ladder of resistors, basically a big voltage divider, and then we have a multiplexer that latches these voltages out to our analog output. So based on a digital input, I'm making a connection between a specific voltage and my analog output. Now with a 0, 0, my value, my digital value is 0, 0. I'm selecting the 0 volts, which comes down to, in this particular simulation, a few nanovolts, right? So basically 0. If I select 1, that connects the 1.67 volts. If I select 1, 0, that connects 3.3, and if I select 1, 1, that connects 5 volts, right? And any combination of those over time produces a varying signal. We can see this little plot down here. This is an analog-ish signal. It's only got 4 levels, so its resolution isn't great, but it's functional, right? This is an digital to analog converter. Now, I'm going to leave the challenge of figuring out how to use the digital to analog converter on our processor up to you. So the quiz at the end of this section is going to be a kind of reference manual scavenger hunt where you'll have to look through the datasheet and figure out exactly what we need to do to set up our digital to analog converter, and then in class we're actually going to use it.